Imagine training a machine to predict outcomes like whether someone will buy a product or not. Today, you'll build your first machine learning model with me. Stay tuned for hands-on learning. Welcome back to the Skillliftt YouTube channel. I am Shahid, your instructor here to make AI ML simple and practical. With over 10 years of experience, I have mentored thousands to excel in AI, and I am here to help you do the same. Before we dive in, make sure to like, subscribe, and share this video so more people can benefit from this knowledge. Ready to take your first step in machine learning? Let's go. Today, we'll train a simple linear regression model based on multiple features. It's easier than you think, and I'll guide you every step of the way. Welcome to this comprehensive walkthrough of linear regression. Today, we'll build a model from scratch, step by step, while understanding the why and how behind the every line of code. Okay, so before moving on to the code and the program, here on the screen you can see the simplest form of explanation we can give for linear regression. Okay, so before you are going through the line of codes, so I request you to pause the video and read and understand the basic linear regression and how it is represented mathematically. So moving on to the code. Okay, so the first step in programming a model for linear regression we will do is importing the necessary libraries. So to kick things off, we start by importing the essential libraries. So first one is the NumPy, pandas, seaborn, matplotlib, and sklearn, okay, and different modules under sklearn. So why these libraries? Well, libraries like NumPy and pandas help manage and manipulate data. Matplotlib and seaborn are for visualization, and scikit-learn provides the tools to build and evaluate the model. So this is our toolbox, and each tool has a specific purpose. So if you run the code, okay, so run this cell, so all the necessary libraries we have mentioned will be imported. Okay, so next step is to create a data set. Okay, now instead of using a real world data, we will create a synthetic data set. Okay, this is done just for the simplicity. Here x represents, okay, x represents our independent variables. Okay, there are three features in x: x1, x2, x3. The target variable y is computed using a linear combination of these features, okay, with some added noise. So this will mimic the real world data. Okay, so next thing is we are creating a data frame. Okay, next we convert this into a pandas data frame for easier manipulation. Okay, so next thing what we have to do is we have to save the data set which we have created, or the data frame which we have created, into a CSV file. Okay, not the Excel file, the CSV file. Okay, so this data frame format is very ideal for visualization and processing. So next, when we run this cell or the line of codes, okay, the synthetic data set is now created and it will be saved in the drive or in the server, Jupyter server. So you can see it has been created 6 seconds ago, and the synthetic data in the CSV format has been saved. So this is the data set which has been created. Okay, so next thing, okay, so the next step is to load and inspect the data set. Okay, now let us load the data set. Okay, let us load and run the cell. So now the data set has been loaded. Okay, so next we will run the code data.head. So this gives us the first 5 rows, so that we are ensured everything looks as expected. Okay, when you run this cell, you can see the first 5 rows of the data set are displayed, okay, with all the features and the target variables. So next, okay, what we are going to do is, the next step is data visualization. Okay, in data visualization we are especially looking at exploratory data analysis, okay, or EDA, which is crucial for understanding patterns and distributions in the data. Okay, so for the thing is like histograms show the distribution of each feature and the target variable. Okay, next we visualize correlations. Okay, a heat map, like a heat map. So a heat map highlights the relationships between features, and high correlation among features or with the target variable often indicates that there is a strong predictive power. Okay, so when you run this cell, okay, you can see there are histograms, okay, everything plotted, and the correlation heat map, okay, it is also plotted here. Okay, and you can see how the different features are correlated with the target. Okay, so the feature 1 is correlated with target, okay, and the feature 2 also is contributing a lot to the target variable, and feature 3 is not contributing significantly. We can say there is no much significant contribution, but yes, there is a contribution from feature 3 towards the target variable. Okay, so the next step is basic data and analysis and statistics. So we will check, we'll have a quick statistical summary. Okay, so this will provide deeper insights. So this reveals the mean, median, standard deviation, and some other statistics for each column. So, and we'll see whether there are any outliers or any unusual values. So this step will expose them. Okay, so when you run, you can see there is a output or display of all the basic statistical summary. So we can see how many number of data points are there in each column. Okay, what is the mean value of each variable, standard deviation, the minimum value within the column, the first, second and third quartile, okay, and the maximum value in the column for each variable, like feature 1, feature 2 or feature 3, even the target variable. So here we can visualize all the basic statistical summary. Okay, so the next step is what we call data cleaning. Okay, so next let's check for missing values. Okay, so here this line print data dot is null dot sum. Okay, so this is used to check if there are any missing values or blank cells within the data frame. Okay, so next once we find the missing values, if there are any, if we find any, we will impute them with the mean. Means the missing cells or the blank cells will be replaced with the mean value. Whatever for feature 1, the mean value is 505.377354. So in the column of feature 1, if there are any missing values, the missing values will be replaced with the mean value. Okay, in feature 2 column we are going to replace it with 498.556929. Okay, similarly the feature 3 and the target variable also, target column also, we will replace the missing values. Okay, so the next, after imputation, we have to check again for missing values. If after replacing the missing the blank cells, if there are again any cells or any data points where we have missed it, we will check it. So when we run this, you can see first it will check for any missing values. There are no missing values. Okay, so then we will do the imputation, but here there is no necessary, because already all the cells have particular data values present in that particular cell. So even after the imputation, the same things will remain, and you can see it will show what is the data type. Okay, so what is the data type which is available in the each cell and each column. Okay, so what happens is the clean data is essential for building the robust models. Okay, if you have any missing values, it will have a very negative impact on the final model. So it will have imputing and finding out the missing values and imputing them with the mean is very essential for building the robust models. Okay, so next is feature scaling. Okay, next we will go through the feature scaling. So here linear regression is very sensitive to feature scales, so we standardize our features. So we use standard scaler to do the feature scaling. Okay, so what happens, scaling ensures all features contribute equally to the model. Okay, so once we run it, so the feature scaling is now done. The next step is we now split our data into training and testing data sets. Okay, so we will run this cell. Now the complete data set is segregated or distributed into two types. One is the training data set, which is 80% of the entire population, and the test size or the test data set, which will be 20% of the entire data set. So here we see that the test size is mentioned as 0.2. It means that the entire data set, 20% of the data points or from the population will be reserved for testing the model. Okay, so this is how we train and test the split the data set into training and testing sets. Okay, so next is model training. What we will do, so here we will create and train a regression model. Okay, so by fitting the model, it learns the optimal coefficients for each feature. So let us see, we will run this cell and you can see now the model has been fit, that is linear regression, for the training as well as testing data set. So the next is model evaluation. Okay, so to evaluate the models, we use this metrics and line of codes. Okay, so we will run this model. Okay, now we can see the model evaluation matrix has been displayed. The mean squared error. Okay, MSE measures the prediction error. Okay, and while the R square score indicates how well the model explains the variance in the data. Okay, so this is what it means to evaluate the metrics. So the next is hyperparameter tuning. Now we will explore the ridge and lasso regularization. In this finds the best alpha value for each model, balancing the bias and variance. Okay, so it will find the best parameters to make sure we have the highest accuracy or the optimum accuracy for the linear regression model. Here we use grid search VCV model, okay, module for grid regression as well as lasso regression to find out how well the or which are the alpha values for which we get the optimum result. Okay, and here we also do a cross validation to check if the hyperparameter is performing or giving the optimum solution every time, and we will do it for 5 folds. Okay, so when we run this, so we will do the hyperparameters. We can see for ridge regression we have alpha value 0.01, and also for lasso regression we have 0.01. It means that the alpha value is 0.01, which is the optimum for getting the highest accuracy for the linear regression model. So the next thing is evaluate, okay, what is the model accuracy of the or performance of the model. So we have to test the tuned models using the hyperparameters. So next, comparing MSE, that is mean squared error, for ridge and lasso, that helps assess the impact of regularization. Okay, so we will run this model and you can see for optimum alpha value for both ridge regression as well as lasso regression, the mean squared error is almost the same. Okay, so next is classification metrics or accuracy metrics. Okay, although our task is regression, let's explore classification metrics by binarizing the target. Okay, so this demonstrates how regression models can be adapted to classification tasks. Okay, so we will just run this. So we can see the R square score. Okay, almost same for both. Okay, next we also plot the ROC AUC curve. Okay, this visualizes the model's classification performance. So we will run this and you can see there is a ROC curve with AUC value, okay, 0.96. Okay, so next thing is confusion matrix. So finally let's look at the confusion matrix after running this model. Okay, so we can see this shows the counts of true positives, false negatives, and so on. Okay, how many have been predicted actually, or true values, or how many false negatives. Okay, true positives, false negatives have been predicted, and so on. Okay, so finally we will conclude by evaluating the rich and R square and lasso with MSc, and summarizing. Let's run this. Okay, so you can see the final precision is 0.98, which is very good. Recall is also higher, 0.94. F1 score is also higher, 0.96, and main thing is accuracy. Accuracy, you can see it's 0.96, means 96%. Anything above 95% is very good, but still there are many things which we can improve to get more accuracy near to 100. Okay, so and that wraps up our end-to-end linear regression workflow. Thank you. Love this session? Imagine what you can achieve in your 30-day AI ML bootcamp starting January 6th. Here's what you learn: machine learning, deep learning, generative AI, build 4 industry-level projects to boost your portfolio, gain lifetime access to resources and certificates. Limited offer. Join for just rupees 499. Seats are filling fast, so register now using the link in the description. Thank you for coding with me today. Don't forget to like, share, and subscribe for more exciting tutorials. Drop your questions in the comments and I'll answer them in the next video.